in which we can see that the 3.5 millimeter of crack is still bearing load and stress. A normal concrete around 0.5 fails. And these values that are reported in the graphs are the mechanical properties of the most common product of this line. So LCM is the cubic resistance, so more or less the mean average cubic resistance between around 120 megapascal. FCK is the cylindrical compressive strength. The E is the Young modulus, so the elasticity. You can see that the stiffness is really higher than a traditional concrete. And this number, FR1K, FR3K, okay, is the characteristic values from which we can define the tensile capacity of the material. It is called the characteristic indirect tensile capacity. And you can see that some products reach more or less till 11 megapascal. For concrete is a huge value. Basically, this value is 0. So, additional test, since we have said that basically this material is poured and applied on an existing substrate in terms of concrete jacketing and concrete topping without shear connectors. Okay, we have also to guarantee and show why we can say that we are not going to use shear connector. So what we made is a shear testing, shear bond test. So basically we have applied our material on 3 different grades of concrete, poor concrete. And for each one of these sample, we have treated the surface in order to have a smooth interface, a rough interface, and a very rough interface. We have applied the material on the top, and we have then make the shear bond test, the top bond test, in order to evaluate which is the maximum capacity that we can reach. More or less in all the tests we reach around 4 megapascal of pure shear capacity. How to check if this resistance is sufficient or not? Basically we can refer to the Juraski formula. You use Juraski here to check the acting shear at the interface. Okay, basically starting from the geometrical properties of the section, so the moment of inertia, the acting shear, and the elastic modulus, and also the effective depth, we are able to calculate which is the acting shear stress at the interface. And most of the time it never overcame 1.5 megapascal. So in this case our material can ensure at least more or less from 3.5 to 4 megapascal of pure shear capacity at the interface. So more than 2 times the maximum acting stress. This is a video. This is a machine that is called trimmer. It's used for roughening the surface, but most of the time the surface is still rough. So in terms of concrete topping, maybe that you don't need for roughening. You can see the preparation of the substrate. It's really important to have a rough surface, because the bonding and the transfer mechanism of the stress is both chemical and mechanical. In this case you can see some steel, but wasn't for strengthening reason linked to the concrete topping. Checking of that the product is able to embed everything. This is the material that is mixed in concrete mixer. In reality, we are able also to pour the material using a pump. nowadays we can guarantee only for one pump and one model that we have tested that can be used for mixing and pumping this material, because the fluidity is really weird, let me say. So it's similar to the Oni. It seems fluid, but it isn't. You can see here the material, and you can see that there are no shear connectors. There is nothing. So transfer of stress is directly made by the addition of the product. This is the day 2. Thickness of application, so more or less can range from 2 to 8 centimeters, pure material. The thickness depends on which is your capacity demand. So if you need to increase more the capacity of a slab or of a column, of course the thickness will be increased. These are examples about column jacketing. You can see here that we were not able to access from upstairs, so we have realized the formworks till more or less 50 centimeters to the top. Pour the material inside the formworks, and the day after we have used the thixotropic material to complete the jacketing in the top side. Other example, still with concrete jacketing. In this case, the original project provides for RC traditional jacketing. We have reduced by half the thickness, and we have eliminated completely the rivers. This is another project we made a pair of years ago, in which firstly we have realized the concrete topping on the slab, and then we should also realize the jacketing of the beam. You can see here the formworks. Okay, how we realize the jacketing of beams by pouring the material from upstairs. We have realized 2 rows of holes. Why 2 rows? Why not only one? Hey. Okay, what? Always one for pouring the material and another for letting the air to go outside, because otherwise you will have voids. And the result the day after is that the beam was completely jacketed without any kind of voids, no honeycomb, nothing. So a completely perfect jacketing. Again, column jacketing, even in this case you can see the formworks harmed because the hydrostatic pressure of the material is really high. So if the thickness is up to a certain limit, we need also to reinforce the formworks. This concrete topping. Okay, in this case was a seismic retrofitting. Okay, so you can see that we have placed steel rebars along all the perimeter in order to let the transfer of load between the concrete topping and the beams and the surrounding element of the slab. Again, the application of the Planetop HPC on bridges. Okay, it's not only a product that can be applied for realizing concrete topping in civil building, but also for strengthening bridge decks. So even in this case, no steel, no shear connector, no electro-welded steel mesh, no steel, just a mortar with steel fiber, able to collaborate without any kind of connectors. The application always in highways. I would like to show you this video. This is one of the products that is called the Planetop HPC Floor 46. So it has gravels of size till 6 mm inside. And what I would like to say here is pay attention at the worker in the top that he is using the trowel for pushing the machine in order that you can appreciate the fluidity, the viscosity of the product. Because it seems to have difficulties even if it seems fluid. In reality, it has a viscosity really particular. This is the retrofitting, so the renovation of a bridge curve in the highways. And even in this case, you can see no shear connector, nothing. This just to show you another product that is part of, somehow part of this slide, of this line. We have realized a concrete curb in which we have installed a barrier in collaboration to what we can call the toll authority in Italy. Then Andy and me took our truck more or less 1 month ago. We drive to Italy and we made this test. In reality, only Andy was driving. It's a crash test that we made close to Milan. You can see the strength of the material to prevent the pull out of the barrier. This kind of materials, since they reach really high performance in terms of compression, means also that the porosity is really low inside. Okay, this is the last graph that I would like to highlight you. There is an example, so it is an M interaction diagram. So basically in the center we have a core that is in light blue, that is the M interaction diagram of an existing column. Then we have simulated to reinforce that column with FRP. So you can see the dominion, so the M interaction diagram of the section reinforced with FRP in the dot orange line. And the dark blue is the same section strengthened with Planetop HPC. You can see that the main difference is that Planetop HPC is more efficient in terms of compression, so in axial bending, compression, axial bending. And the FRP is more efficient with respect to the tension capacity. So in your case, the graph is rotated at 90 degrees. Yes, but the concept at the base is the same. Okay.
Oke, mungkin tadi pertanyaan tampung di belakang. Kita sekarang maju ke Mapei Italia System, materi terakhir untuk materi perkuatan struktur di hari ini. Oke, jadi tadi bahas sedikit juga mengenai HPC ya. Mungkin di Indonesia kita belum belum pernah aplikasi untuk SPC dan mungkin ini teknologi baru sekali. Jadi kita komparasinya dengan jacketing system pada umumnya, gitu ya. Jadi dengan menggunakan steel kombinasi material mortar dengan steel fiber, itu kita bisa mencapai kapasitas tadi 130 megapascal dengan tidak usah menggunakan added tulangan lagi di existingnya seperti itu. Mungkin ada sharing-sharing sedikit, mungkin ada beberapa ibu sekalian yang ada case-case untuk jacketing system, mungkin ada yang bisa di-share di sini. Oke, mungkin kita coba break dulu. Kita Umberto lagi coba share, cari dengan materinya. Oke, sebentar.
Okay, sorry, but we have brief technical problem. Solved. Okay, last topic of today is a really short topic. Is the Mapei ecosystem. EQ stands for earthquake. So basically, it is a system realized with a glass fabric. That is this one. Okay, biaxial glass fabrics. That has been developed in order to prevent the overturning of the walls. So basically, this is a mechanism really common during the earthquake, and I think that even in Indonesia can happen something like this. So basically, it could happen that the reinforced concrete elements are completely undamaged, so without cracks. But what you can see is that all the infill walls can be damaged, can be overturned out of plane or in plane. So why we have to take care about also the infill walls? Because the infill walls, by overturning, can develop damage to people or to things. So it means cost. Okay. So there are also some buildings that has to be maintained operative even during the earthquake. So government building, hospital, school. So in this case, I think that we have also to take care about the life of the people inside. That's why more or less 10 years ago we have developed and introduced this system. This is basically realized with this kind of glass fabrics. It is bidirectional glass fabrics, and the main characteristic of this system, the main innovation, is that this kind of glass fabric is applied directly on the render. Okay, if you have an existing building, there is no need of damaging anything, no need of removing anything. You can apply directly this material on the render, on the plaster that you have already installed on the wall. And the second main characteristic of this material is that it is applied using a polyurethane-based material. It is really elastic, and it is water dispersed polyurethane adhesive. So this means also that this material doesn't affect the water vapor permeability of the infill walls. Why I like this? Because if you use an epoxy resin, the epoxy resin completely block the water vapor permeability. So this means that you can have a condensation inside the building. If the mechanics air conditioning system is not well working. This material is able to maintain the transpirability. Okay. So the application is really simple. So the only operation to do is the removing of the painting, because the painting is a film that block the possibility of the adhesive to enter in the pores of the plaster or of the render. So it is really important to remove the paint. So remove the paint, apply a first layer of polyurethane adhesive, install the glass fabrics, second layer of polyurethane based the polyurethane adhesive, and then after 24 hours we can apply the render on it. And that's it. How we can call it? Like a seismic wallpaper? Yeah. Okay. These some tests that we made. You can see that this sample has been undergone a 3-point loading, 3-point bending loading test. So up a certain amount of load, we reach failure, and it suddenly break in the middle and collapse. By applying this material, we face the same, so the complete failure of the element, but this glass fabrics was able to maintain a certain capacity. So imagine if you need also to guarantee for evacuation. So in this case, the elements are broken, but you have time to go out from the building. And that's it. Okay, we have done. Okay. So if you have any question, we can conclude having some question. Andy?
Oke, jadi materi sudah selesai. Jadi kalau ada pertanyaan, mungkin silakan Pak. Bu, ada pertanyaan? Sambil mungkin nanti bisa coffee break juga. Nah, kita santai aja. Mungkin di sini santai, bisa coffee break sambil Q&A. Any question? Pertanyaan? Kita mau discuss.
It's okay.
The question is for the example is from the masonry from top to bottom without any opening. How you deal it with if there is any opening at the wall?
Okay, so basically, this kind of system, the ecosystem, is quite new technologies, but we already apply it here in Indonesia. We've done prevention of overturning in an industrial plant, big wall. Maybe Andy can share with you also some pic. I'd like to see.
Oke, jadi produk ini hanya Mapei teknologi yang kita create. Jadi juga ini seperti wallpaper juga, kita bisa juga buat semacam customize gitu.
Technical service, please. No. Okay, basically, coming to the question, so even if there are openings, it makes no much problems, because basically this kind of material is applied in vertical, okay? and the capacity of the system is linked also to applying the material above the structural element, because we are gluing the infill walls, we are gluing these fabrics on the infill walls, but we have to extend this kind of material till the concrete element. So if you have a slab or a beam, you have to just extend the fabrics till the beam. And since it is bidirectional, what we do usually is to apply horizontal strips at the bottom and at the top. Yes, I wanted to show you the pic, but okay, now it works, because my colleagues wanted me to stop earlier today. So this is a typical application. The overturning of a building, for preventing the overturning of the infill walls in a civil building. You can see that here we have the openings. We have applied simply the material in vertical, and then in the top of the windows and in the bottom side of the windows we have applied the horizontal strips in order to connect with the other vertical ones. Overlapping should be at least 15 centimeters between each strips, and we then extend this material till the concrete element, because the purpose is to connect, let me say connect, the infill walls to the concrete element. And in this case we have also made the ethics. I don't think you're used to apply insulation. So you can see typical applications, so all vertical strips overlapped by 15 centimeters, and in the bottom of the window an horizontal strip. Please.
This is also patented technology of Mapei. So we
Yes.
created, we have a global patent. Mapei is a founder of this technology, and also it is patented under us for 10 years.
Yes. You will not find this kind of technologies anywhere else. So no one of our competitor has this kind of technology. And usually when we deal with the structures, we don't use polyurethane-based resin. We used to refer to epoxy. This is, let me know, also the only polyurethane-based resin used in a structural application. And if you want to add something about the intervention we made here in Indonesia using ecosystem.
Pardon.
You remember?
Yeah, spending.
No?
Spending.
Just the general detail without providing name or references.
Yes.
So in reality, we already checked that this technology can comply with your needs somehow, can solve some of your problems, or maybe some of the problems of your customer. And now we are dealing with this project in which we can give only general detail about geometry without naming or position or who is the customer. But we've done a mock-up.
Yes, yes. Ya, jadi kita punya salah satu proyek yang sudah dikerjakan di Palu ya, menggunakan ecosystem untuk overturning walls. Jadi kurang lebih sekitar 1000 square meter persegi untuk diaplikasikan di overturning wall di area di Palu sana seperti itu. Jadi mungkin kita bisa collaborate. Memang ini mungkin di Indonesia mostly tidak menggunakan seperti ini, tapi untuk protective earthquake untuk area wall kita bisa provide menggunakan sistem seperti ini. Ini juga bisa diaplikasikan di ceiling. Do you have some picture in the ceiling?
Yes.
Bisa diaplikasikan juga di area ceiling.
Yeah, in the ceiling, but okay. I don't think that you will have this kind of application because basically we apply also this system to prevent the falling of the hollow core slab we have in Europe, because I think that in Indonesia you only have concrete slab. Yes. That's why better not to use. Okay, so personally, I would like to thank you all for being here today. For me, it is always a pleasure to join Indonesian colleagues and you here to share knowledge, to have comparison between two points of view maybe sometimes. So I'm quite excited to learn every time something new from you because it's always an opportunity. And I hope to see you soon. To say. So thank you very much. Terima kasih.
Kita ada kopi break dulu Pak, Bu, silakan kopi break. Nanti setelah kopi break kita ada sesi foto bersama, setelah kopi break. Mungkin dipersilakan kopi break lebih dahulu.
Mungkin sambil coffee break, kami akan membagikan sertifikat training di hari ini. Namun bagi rekan-rekan nanti apabila ada yang belum mendapatkan sertifikat di hari ini, nanti akan kami kirimkan menyusul. Dan tadi ada yang mungkin ada beberapa terdapat kesalahan penulisan nama. Nanti mungkin kami akan tahan dan kami akan revisi, nanti kan kami kirimkan kemudian. Gitu. Nanti mohon dicek kembali memang apabila ada kesalahan penulisan nama, nanti mohon kami diinformasikan supaya kami bisa revisi dan kami kirimkan kembali. Ya. Kepada Ibu Ariasa Pradeni, boleh tunjuk tangan? Oh, maaf. Boleh, kalau boleh saya tanpa Bapak dan Ibu ya, saya takut ngomong. Mohon maaf. Angga Bayu Kristianto, Agus Supiat. Oh, nggak ada. Nanti sekali lagi mohon dicek kalau ada kesalahan penulisan nama, kita mohon diinformasikan. Andika, Ahmad Sobar Nurul Sodik, Arga Sandi, Cindy Gunawan, Dimas Aryo Suseno, Basrindu, Dwi Yulina Abdi Jayanti, Emmanuel Trinugroho, Febrian, Firna Sofia Ibu yang di Ferry Uswadi, Felicia Gabriel, Gugun Nugraha, Galuh Ade Putra Hardiansyah, Hendri Su, Haikal, Ivander Oswin, Imam Rojikin, M. Tirafi, Marvin Satyawardana, Michael, Maya Iskandar, Muhammad Ayib Arifin, Maria Marwan, Nur Rizki Aulia, Odi Pratama, Pandu Yuda Kesuma, Paul Aprianto, Ria Ananda, Richard Kevin Lee, Rizal Nur Syamsu, Robi Hawinardi, Sucendro Prasetyo, Steven Putra Limanto, Surajin Sucipto, Syarika Sucipto, Suherman, Theo Sebastian Sudirjo, Valentinus Nanang, William Suparjo, Wimala Kitri, Yoga Rian, Yeremia Leong, Yumi Meirina. Ada bagi ada perwakilan. Mohon dicek kembali apabila ada kesalahan penulisan nama, mohon diinformasikan kepada kami. Nanti kami bisa perbaiki. Sama yang belum dapat boleh ya nanti boleh diinformasikan ke Mas Hendy sebelum pulang supaya kami bisa susulkan sertifikatnya. Ada yang belum jelas sampai sekarang, sampai saat ini? Ada yang salah nulis nama, mohon maaf. Semoga nggak ada. Kalau ada nanti kami tolong diinformasikan Bapak dan Ibu. Mungkin sebelum kita memasuki sesi foto bersama ada pertanyaan lagi terkait sesi training di hari ini, baik mungkin pada saat di classroom maupun pada saat demonstrasi aplikasi produk Bapak dan Ibu. Monggo kami buka kembali sesi pertanyaan apabila ada. Ya, monggo.
Saya mau bertanya sedikit mengenai pengaplikasian FRP. Itu apakah memungkinkan kalau kita mengaplikasi FRP itu di area yang basah atau misalnya tangki air seperti itu? Nah, apakah itu mengurangi efektivitas dari epoksi?
Oke, terima kasih Bu pertanyaannya. Jadi FRP aplikasikan tidak bisa Bu, karena ada faktor kelembaban juga. Tadi 4% ya. Jadi kalau misalkan itu kita tidak bisa mengaplikasikannya, nanti akan terjadi FRP tidak akan bonding dan akan terjadi delamination. Mungkin ada lagi pertanyaan yang lain? Oke, mungkin dipersilakan kita ngomong.
Ya, masih sedikit pertanyaan terkait bagaimana koneksi anchorage FRP ke pondasinya. Karena kan kalau tadi kolom join udah gitu kan ya. Kalau ke pondasinya gimana ya?
Kalau ke pondasi sama perlakuannya Bu, jadi kita menggunakan FRP angkur untuk apa namanya anchoringnya. Sama untuk anchoring kita menggunakan FRP angkur seperti ini. Nanti kita diaplikasikan untuk sekeliling apa namanya si kolom ke PLCAP-nya seperti itu. Sama layaknya kita aplikasikan tadi di pada saat jam ke kolom itu sama. Mungkin ada lagi.
Pak, tadi kan disebutkan HPC itu bisa digunakan untuk mereduksi getaran lantai. Kalau contohnya kan tadi diaplikasikan di sisi atas. Kalau misalkan di sisi atas itu kan maksudnya ruangannya digunakan, memungkinkan nggak itu diaplikasikan di bawah di antara span balok ke balok misalkan?
Oke. Kalau di bawah itu saya tidak bisa karena materialnya semi fluid ya, jadi bukan seperti apa namanya grouting yang bisa dikasih di atas. Ini materialnya fluid, jadi tetap tidak bisa, harus dari atas aplikasinya. Karena kalau enggak dia akan sagging ke bawah. Tetap harus dari atas sih Pak. Oke, ada Mas.
Mau tanya, semisal apakah bisa FRP dipasang di plat atas, maksud saya di bagian tumbuhan, kan otomatis bagian atas. Nah, itu semisal di dermaga kan akan dilalui truk, itu gimana? Apakah bisa memungkinkan?
Bisa, tapi tetap harus diproteksi lagi Pak di atasnya. Karena FRP tidak bisa langsung dilewati oleh heavy traffic. harus di topping lagi di atasnya Pak.
Lagi
Ya.
menggunakan grouting atau
Menggunakan ya grouting bisa yang untuk tinggi pastinya gitu. Sesuai dengan desain dari slabnya butuhnya berapa megapascal gitu. Tapi tetap harus diproteksi Pak, tidak bisa langsung terekspos.
Saya ada dua pertanyaan. Yang pertama untuk yang perkuatan infill wall menggunakan BMQ tadi. Kalau misalkan di lantai di atasnya itu menggunakan bondek dan pas ketemu dirinya itu kan harus di overlap. Nah itu overlapnya ke atas gimana? Terus yang kedua kalau untuk perkuatan dengan pelat untuk balok itu sebenarnya kalau secara teoretik kan yang perlu diperkuat itu kan di tempat di mana kapasitasnya kita mau tambah saja.
Ya.
Nah itu apakah ada diperlukan panjang penyaluran lagi seperti tulangan atau tidak perlu?
Oke, mungkin untuk yang tadi bonek itu kita bisa diaplikasikan bisa di overlap di boneknya. Nanti kita koneksinya menggunakan epoxy adhesif Pak. Tadi ada material yang pasta tadi yang untuk bonding si karbopret ya. Itu bisa kita overlap sekitar 15 cm ke area bondeknya menggunakan material yang epoxy adhesif. Itu bonding Pak. Nah untuk yang pelat itu tetap ada overlap itu, tapi tetap nanti kita harus tanya dulu ke konsultannya berapa momen envelope-nya, karena nanti ada perhitungannya juga di DCI. Kita harus tahu momen envelope-nya dan pasti tadi mutu-mutunya ya. Nah nanti bisa kami propose juga untuk perhitungannya. Tetap ada panjang penyaluran.
Yang mau saya tanyakan itu untuk FRP sistem berapa maksimum layer yang bisa kita pakai gitu? Ada limitasinya kah? Mungkin linear berapa bounce-nya mulai turun gitu?
Usually biasanya kita menggunakan maksimum 4 layer, maksimum the layer of the FRP 4 layer.
Number of layer.
Okay.
Let me say that there isn't something defined by in the ACI for 4.0. Okay. The only reference that we have worldwide is in the European guideline, and provide to not overcome 5 layers. In our experience, what happens? If you increase the number of layers, you are also decreasing the capacity of the system. So if you put 2 layers, you won't have double the capacity of 1 layer. So the increment in the capacity is not linear. So do something like an asymptotic curve. So in our experience, we advise to not overcome 4 or 5 layers at least. But it's an advice. There isn't a rule.
Mas Edi, yang terakhir nggak kedengeran dari belakang, boleh pakai mikrofon.
Oh ya, jadi ada kenaikan FRP itu bukan misalkan kita tambah 50 kN kali 2 bukan. Jadi ada semacam faktor reduksinya juga. Jadi bisa kurang dari double-nya gitu. Kurang kali 2-nya.
Apakah ada maksimum kelebihan DCR dengan capacity ratio yang bisa ditangani oleh penambahan FRP? Apakah ada batas persentase kelebihan DCR atau dengan capacity ratio yang bisa ditangani oleh penambahan FRP? Misalkan kelebihannya 50% nggak bisa ditangani gitu.
Consideration in terms of increment.
In terms of, is there any maximum limitation in percentage of the exceedance of DCR, the demand capacity ratio that can be fixed using the FRP digit?
Basically, no, there isn't any kind of limitation.
So 100%.
Yes, you can achieve whatever the capacity you need, but I'm not the best, otherwise, okay, you can I can draw something. Okay. Sorry. Yes. So imagine that this is your existing beam, okay? And you have moment due to dead load and moment to slide load. Okay. The existing capacity of the beam should be at least higher or equal. Then we will go to FP to M dl plus 0.75. Okay, so this is your existing situation. Okay, this is the only limitation that you have to check. Why there is this limitation? Because imagine if you have applied your FRP or your FRP here. Okay, if something happened to the FRP, mechanical heat, some damages, fire. So these relations is saying that without FRP, the beam should be able to provide a safety level. Okay, but beside of this limitation, in terms of increment, so from MMN to the M reinforced, okay, here you can reach even up to 1000% of increment. You have no limitation with that.
Thank you.
Hope it's okay. Okay. Other question? Other topics? No more question?
Mungkin kalau sudah tidak ada pertanyaan, kita bisa foto ke depan dulu untuk foto bersama. Jadi nanti sebelum, mungkin apabila nanti ada pertanyaan lagi, boleh langsung serbu dua orang yang ada di depan. Nanti setelah kita foto bersama. Ya, monggo kita persilakan untuk bisa maju ke depan. Kita akan melakukan foto bersama terlebih dahulu. Kami persilakan.
Thank you again.
Monggo kami persilakan untuk bisa maju ke depan. Silakan, silakan.
Fine. So for me, it's always a pleasure to be here in Romania. So for how long was it? 1 week? Yeah, last day and tomorrow will be time to come back to Italy. Come back to winter. But
mari kita atur posisi menentukan prestasi.
Next time, I hope about that. Because Andy wants me only to work, nothing else. Thank you for being here. Thank you.
Mungkin ada di depan sedikit di belakang yang
mungkin bisa dibikin 2 layer Bapak dan Ibu.
Ya, itu yang tinggi di depan, lebih tinggi lagi di belakang.
I would like to invite Mr. Oleh to officially close the seminar today.
Thank you very much again for coming and exchanging information, listening our experiences on our solutions. I hope you enjoy it. I hope we were able to give you some window, some different ideas. Like I say, I think Indonesia important. The EMAS 2045 is also, and all of us here is responsible. I wish everyone good luck and thank you again for coming in. In case you need something from our side, please feel free to communicate anytime. Thank you very much.
Terima kasih sekali lagi kepada Bapak dan Ibu sekalian atas kehadirannya. Jika ada yang bisa kami kolaborasikan, kita bisa dikontak ya dengan senang hati. Oke, sekali lagi terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you.
Thank you very much. Thanks for coming. See you.
Andy. Okay.